Welcome to Meteorology 101. There's a lot happening in the weather world right now, and the biggest question is how much snow are we going to get? So we're going to pull up a few models, some some charts, maybe look in the upper levels, see how much time we have here, um, get a good idea, see what we can come up with. So here's the latest satellite loop for the low level water vapor. And just looking at this chart, looks like some convection off the west coast of Florida. Actually, there was a pretty good cell. It looks like popped off up off the west coast of Florida and just dissipated before it got inland. Another cell developed over off the east coast of Florida that dissipated as it went out to sea. We got looks like some rotation over the four corners, like a low pressure system over there. We know that big high pressure system that's ridging down into Texas, all the way down into Mexico. That's present. That's all the cold weather that caused all that sleet, freezing rain in Texas, caused all those accidents. And then we had that inverted trough over the East Coast, and we'll get a good look at that. So, looks like high pressure off of the West Coast over the Pacific, just ridging in. Not a lot of it coming inland just yet, but that should push into inland. Now this low pressure system, I believe we looked at the models last time, that was going to push south. It can't push the high out of the way, so it has to go around it. So it's going to push south, come around that high, and then redevelop over here over the Gulf, and then push to the northeast. So that's our steering pattern right there in the low levels. You can see that flow. So anything that develops in here is just going to continue to the northeast, especially with that high pressure system over the central U.S. All right, let's get a look at the radar real quick. And a lot of the scattered stuff through the center, that's just radar picking up maybe some isolated snow showers, just a reflectivity. I mean, there's a lot of stations out there reporting mist. So maybe some mist, fog, and the high pressure got that low level moisture subsided down onto that low level moisture, got it capped off and just creating some low visibility. So the radar's picking up, some of that moisture there. Great Lakes region covered in snow, lake effect. See what low pressure systems up there. If that inverted trough along the east coast, it could be stretching up into there. Want to see how that developed, if it deepened or not. And then, like we said, that low pressure system over the four corners. You see any rotation now? You can see where your frontal boundary would be if you had to place a front through here. We got that mixing. We had that inverted trough, pretty much just like a stationary front. We've had like a cold front undergoing frontalysis become stationary over the east coast, just sitting there, and then coming down into what looked like a low pressure system or a trough down in the Gulf of Mexico, and then you could just bring that stationary front right around into Texas. Now you can see where you have some isolated areas of some freezing rain or mixture, and then a little bit of snow to the north. So that stationary front pretty much separating these air masses, just going right around that high, coming up into the north of New Mexico, Colorado, and then going headed to the west. Looks like through the mountains, upper elevations, and then we did have that quite a bit of snowfall in the upper elevations, and that looks like that's continuing in the northwest. So they're getting a pretty significant amount of snowfall up there. So our question is, how much snowfall are we going to get? We got that pressure system, that snowstorm coming through the Ohio Valley, and then pushing to the northeast. We had all that ice through Kentucky, that big ice storm, and then that pushed through the Ohio Valley, and we got right around anywhere from 6 to 10 inches through Ohio. And then now we're expecting another one to be pushing through over this weekend. Basically, I believe Monday night into Tuesday is going to be the biggest part of it. So let's get a good look at the synoptic situation on the charts, and let's see what's going on there. Alright, so this is We're going to start with a blank canvas today. We're going to pull sea level pressure. We're going to pull some station plots, look at some temperatures, and pull the isotherms. See where we have any kind of thermal advection, and just see how this high pressure has developed and how that trough has developed also. Let's go ahead and pull the surface plots for now. Alright, I'm on the wrong chart here. Let's see what level I am at. I'm at 500 millibars. I'm going to drop this down to the surface. So let me erase that and start over. Should see quite a few more plots than that on the surface. Alright, here we go. Looks like in the red, off the east coast, over the east coast is IFR conditions going into marginal VFR, and then we have those isolated patches through the central United States. That's looks like some broken sky, some clear skies up to the north, overcast to the south, and then still reporting snow in northern Texas. Then looks like mist, lowered visibilities, some snowfall over Colorado and Nebraska, and that would be lowering visibilities also into IFR conditions. And then over the Utah, Wyoming, looks like some snowfall and marginal VFR conditions. Now look at these temperatures over here. Like we said, if that front was still coming down to the through the east coast, we're just guessing right now. We'll put our isobars on here in a minute. We were saying that stationary front coming down to the east coast, it has to go around the high pressure system, separate that air mass, go back up. But we're going through New Mexico, through Utah, and back up off the west coast. So look at these temperatures. You got a 45 and a 36, 26 degrees in Nevada, 39 degrees over western Nevada, 56 to southern Nevada. So there's a pretty good drop, 26 and 56. So you can pretty much definitely say there's a separation right there. 53 to the south in South New Mexico, and 37 just to the north central. So that's continued to be a separation. 33 well to the south in southern Texas, and then 64 over Mexico, 71 over the Gulf out of Bowie, 49 over the Panhandle of Florida with rain, and then we have all that rain that we've seen on the radar all through the southeast. We've got quite a few areas of mist. So anytime you're placing front, you're looking for a temperature change, mainly when you have that cold air mass behind that front, and then you're looking for a wind shift. Now, we did see that low pressure system over the four corners. If we look at the rotation, we do have a northerly wind going to northwest, west-northwest, and then still kind of a northwest there. So we do have a little bit of rotation right there. So if we had to place that low, it would be just right over Utah. Alright, so let's go ahead and throw our isobars on there, and we get a better idea of where all these low pressure systems are and high pressure systems. So alright, low pressure system a little bit further to the south than I said. If you look at the winds, I mean, the computer's placing that low, so that computer may just be a little bit off too. So it looks like the tightness of these isotherms there, we got that low pressure system, just the high pushing to the south, the low pressure system pushing to the north, trying to, and then because we had that flow that looked like a low level trough, which it is, it's over a low pressure system trying to steer this to the northeast, but it can't push the high out of the way, so it's going to eventually have to go south. So but the isobars are just pushing pretty tight, but I'm not really seeing any significant winds through that. So if we throw the isotherms on here, then we can get an idea where our advection is. So if we look at, what we're looking for is anywhere these isotherms cross the isobars. They're It's really not a lot going on. That's a barotropic, looks like a mainly barotropic high. Cold core high. You can see that isotherm. Let me pull this up a little bit. Negative 30 isotherm. This is negative 30 degrees Celsius on the surface right there. That cold core, just a cold core high. It's the Arctic air. And we know that is just pushing air, all that cold air, all the way to the south. So we do have a little bit of advection from that low pressure system. These isotherms are warmer to the south, so the low pressure air, the wind circulates counterclockwise around the low. So we have warmer advection from the south. So that warm, moist air, any moisture it's picking up off the Pacific, or anything, these isobars are going onshore flow into northern Mexico there, then we could have any moisture advection, and then that getting pumped up in that low pressure system, and then riding onto that ridge, and then any precipitation that falls through that ridge will fall as snow because the freezing levels are so low. So a little bit of a warm air advection there. To the back side of that low, we do have that high pressure system over the Pacific. I have to get over there and see what's going on with that. If that's a big low or warm air advection. So yeah, that was we seen that ridging, you know, that moisture just spilling over that ridge. So this ridge building up into the west coast, and that moisture from that low pressure system, like an Aleutian low, that's just pouring moisture right over that ridge. And then this low pressure system over the four corners, like I said, some weak thermal advection from the north, so maybe have a little bit of a cold front extending out behind that. We'll see, definitely have that because you have a 54 degree temperature in central California, and then to the north of 39, so you got to separate that with that air mass. So we'll let the computers throw these fronts on here. This gets pretty messy. Sometimes I just like to draw them myself. It takes a little bit too much time to do it on these videos, but we'll throw these fronts on and just to see what we're working with. Alright, so it also doubles the lows, doubles the highs. I mean, so it kind of clutters that up a little bit. But you see cold air, a cold front coming out of that low pressure system. I would push that a little bit further north. That stationary front actually coming down. They got placing a couple lows in there, but that's not all there. Depending on thermal advection, I mean, based on these isotherms, I don't really see any. Now, maybe right here. That's an inverted trough. You got mainly troughing, not really so much of lows, but that stationary front pushing on down, and then down into Mexico and back up, separating that air mass, and then feeding right back into that low over the four corners. So that kind of makes sense. And then some inverted trough. I'm gonna get rid of that. So now that inverted trough is going over the Great Lakes region. We have, if you look at the radar, there's quite a bit of snow over the Great Lakes today, and that was it's still snowing up there in northern Wisconsin, right there in southern Michigan. So New York, maybe that's Syracuse or Buffalo. So pushing, still got some significant snowfall over that area. Alright, so we can go, like I said, I know the big question everybody's waiting on is how much snow we're going to get. Let's go pull up some models real quick. We may hit the upper levels. Actually, let's go hit the jet stream real quick, just to see where this jet is and what has support. We'll just pull the shading, and then this is at 300 millibars. So we do have a jet finger off the west coast, and then pretty much, I guess that'd be the long wave ridge over that high pressure system, and then the jet max off the east coast. Let's throw the pressure on just so we can get an idea what the flow is here. So we do have a little bit of troughing over the west coast. That's just around 300 millibar. Now I'm gonna have to throw the isotherms on because I'm gonna see it's barotropic, which I expect on a 300 millibar. showing a closed low over the over Canada, and that's still a baroclitic system. Closed low baroclitic to the north, so that would explain that. Basically, it would have to be like a huge occlusion, and then just that cold air would then it just becomes barotropic to the south. So it's kind of strange. -48 to -50, so we do have that warmer advection to the north over that Great Lake region. So there's your, if you have some warm moist air, you're picking the moisture off the Great Lakes, and then the warm moist air over the Great Lake region, like a frontal boundary, giving that lift that would cause support for all that snow over the Great Lakes, and then a cold front to the west of that. But that's a pretty impressive system being closed at 300 millibars. Let me go to throw some. Pump this up a little bit to get all these plots when we're in the upper levels. We got to get as many plots as we can see. So now we got pretty much moisture all through the upper levels. The moisture is extending. That moisture on the east coast is extending all the way up to 300 millibars. Looks like you have a dry pocket in the center of that ridging. So just that cold air subsidy on that in the upper levels over northern Texas, Panhandle, Oklahoma. Clearing that out maybe. Not really any moisture, but this all these black solid dots is moisture, and that's cloud cover. So if we do this, go to just throw some plots up there. And now I'm getting veered off a little bit here. I was going to go straight to the models, but I want to see what let's get a good look at our moisture. I do want to pull a few more charts on this program for instability, precipitable water. That'll give us a good idea of what how much snow we should expect too. It's current precipitable water, so it's not forecasted, it's actual data, so you can see what's in the air now, and if any of that stuff precip falls, it'll give you an idea of how much precipitation is going to fall. So to the northwest we have moisture to all that on the east coast is stretching all the way up into the upper levels. This is where I say all the black, that's supposed to be moisture. See, this is dried out a little bit more there, so the computer's a little bit off today, but not too hateful. The main thing you're looking at is that east coast, and then keep an eye on that low pressure system over the four corners, because that's that low pressure system going to drop to the south. So how intense that is all depends on a lot of things too, but running against that high pressure system can't run against it. The high pressure probably just will spill into it, fill it a little bit, it's going to weaken, push around to the south around that high pressure system, and then once it gets on the other side of that high over the Gulf of Mexico, then it will start to deepen more and then become a system that pushes up. We'll have to see how that all plays out. So let's go pull a couple more charts on here before we get to those models. Let's just see what's the actual data. We want to look at, this is the real-time stuff right now. So with the forecast models, they change every day, and you got all your forecasters, that's pretty much they go by the forecast models every day, and as these models change every day, they don't make a decision. Even though right now, the way all the news stations blew it last time on the amount of forecasted snow, they don't want to do it again. So because everybody hates their guts for a month, and so they don't want to tell you how much snow you're going to get. They just want to emphasize the impacts of the snow. So it's going to be an impact, whether it's 5 inches or 20 inches, it doesn't matter. The impacts of the snow is what you need to look at, not the amount. So they're all afraid to say anything. All right, let's get I want to pull up. I got a lot of stuff we can do here. Let's see. Let me get this back to the surface first, because that's where we're going to be working at. So surface frontogenesis, this is basically going to show anywhere any fronts are, whether they're going to strengthen or they're going to weaken. So that low pressure system over the four corners, that frontal system, that would be undergoing frontogenesis, which is frontogenesis is the intensification of a frontal system. So frontalysis, where that stationary front is, frontogenesis, where the low pressure, it's showing a low pressure system over the Gulf, and then that's all an area of frontogenesis. So that low pressure system comes down and pushes to the south and then redevelops over in the Gulf in an area of frontogenesis that will intensify. And then the off the east coast, that there's a shows like a low pressure rotation there too. So and that would undergo frontogenesis. Anything in the light blue would more be going under frontalysis, and that just means it's falling apart and becoming stationary. So just for fun over here, we throw these isobars on there. That way it just gives you an idea what you're working with. The low pressure system over there, over the four corners, and then that inverted trough with that stationary front running through that. So alright, that's the frontogenesis. Let's get into the good stuff with this precipitable water. We want to see what potential instability, potential precipitable water here. I got one that we can do precipitable water with snow lines. So to show the snow lines at the different levels, so any of the precipitable water that may fall, where it will fall with snow based on those lines. Alright, so there's the 540 line. Cold air. This is just kind of extrapolating out here because there's not a lot of data at that one. That's what that's doing. I would take this 540 and just connect it right through there. Same thing with all these. They're all, this computer generated, it just pushed them all to the south. It just went out here and just went straight line. I would connect all those just as a trough. Just that cold air mass just coming down into Texas. That's where your freezing line, your rain snow line is going to be. So if you look at all these snow lines pretty much pushing through the Midwest and up into the Ohio Valley, that's where all your mixture is going to be. Anything to the north of those, I mean, you gotta like, okay, say take the north one, the 1530, then down to the south one to that 1290, and then just that big area of possibly mixed precip. Now, depending on the freezing levels, where you'll actually get icing, sleet, freezing rain, or snow. So, but the precipitable water amounts we're looking at is, I probably had to take one, let me go remove a product, so I'm going to remove one line. I'm trying to clear some of that out so we can trace these lines. Let me get over here. We can do, okay, so I got a 0.2, 0.3, 0.4, 5, 6, and 7. So 2/10, 3/10, 4/10. So we have some pretty good amounts of precipitable water in the atmosphere. So if we go through the Ohio Valley, try to trace this one out. This is like a ½ an inch right there. Bring that down. Let's trace it out. So anything along this line, precip will be about a ½ an inch. So that'd be 5 inches of snow. Anything along that line, 5 inches of snow. Just to the north of that is your 4, be 4 inches. And just to the south of that would be 6. Now you gotta remember, if you're in the in those lines of freezing rain or snow or whatever, so 4, basically through the Ohio Valley, 4 to 6 inches right here. That's if the precip that's actually out there right now were to fall, and then it all depends on where your 540 line is. Like, let's do this. Here's your 540 line. Like I said, I would take this 540 line, just cross it right there, connect it right there. There's your 540 line. Now that 540 line, now this changes as the atmosphere changes too. So when the sun comes up, it gets a little bit warmer, that 540 line will move to the north. When it gets colder overnight, it drops to the south. So, you know, that thing does vary, and you gotta take it with a grain of salt. It's just a tool. It's not a for sure thing. So right there through the Ohio Valley, I would say most of that's going to be pretty much snow. So you're looking at about 5 inches of snow right there. That's what the precip that's in the air right now. Now, as the low pressure system builds, you know, or deepens this inverted trough, and you pump any other moisture into that, then that's going to change. So let me get out of here and go look at something else. What else we can build here? Now there is one chart that is used for convection, severe weather, chances of severe weather, but it could be used for systems like this too, just to get an idea of what, you know, the stability of the atmosphere. Now, real quick, we can do a thickness chart. That's just going to kind of show, I mean, really just where the 540 line is, and it's 1,000 to 500 millibar thickness. So it shows basically how thick the atmosphere is at those levels, from 1,000 to 500 millibars. 1,000 millibars is about 364 feet. 500 millibars is 18,289 feet. So between those levels, what your thickness is of the atmosphere, of how the troughs and ridges go through the United States. So we know we got that strong ridging all the way from Canada all the way down into Mexico. The low pressure system over the four corners, and then our 540 line going right through. You see it's south of the Ohio Valley, and then going straight through Kentucky. Looks like just where you're going to have all your mixture. Kentucky's going to get hammered with probably some mixed precip again, snow, icing, you know, the ice storm, and then, I mean, even over the southwest, man, you got this high pressure system. That cold air is just pushing through and down into the four corners with this ridging all the way down into Texas. So most of your stuff in the northern Texas over the panhandle, any precipitation that falls there, then anything north of that 540 line should be snow. So that is a pretty good placement of that 540 line. See how it closed it there instead of dropping it off. The other chart just kind of, you know, pulled those lines to the south. It was just the computer system got confused. So that's why you have to interpret this stuff yourself and understand what you're looking at. All right, so no, I'm not responding. All right, I'm gonna have to take a break here for a second and see if this thing's going to come back or if I'm gonna have to restart the program. Alright, cleared out. So now, let's go see what else we got. Like I said, we had the one with the convection. Let's go pull that real quick. Let's just see what it looks like. Hasn't been doing a lot for the last few days. But with these low pressure systems developing pretty good, it may actually do something. Yeah, it's pretty weak there. So convection over Florida, that was kind of accurate. We did have that convection off the east coast and the convection off the west coast, you know, pushing into Florida. Maybe it was a little bit further north, but, you know, depending on the age of these charts. And then that pressure system off the west coast, you know, that's definitely an area of, we've seen all that moisture just spilling off right along the west coast. So that was working out pretty good. Let me go see. I got another one that runs this chart a little bit stronger. I kind of don't use it for this kind of stuff, but here we go. Now this one, still the same thing right there of Florida, that low pressure system, all that inverted trough, and then right there at the four corners where that low pressure system is, and then the low pressure off the that Aleutian low, that's all off the west coast. So now look at the to the north where that low pressure system was up there. We got a little bit. I mean, that's just, it's so cold that, you know, not a lot, you know, obviously not a lot of convection, but, you know, a little bit of instability over the Great Lakes region. So some significant precipitation over there. Alright, so let me scroll through here one more time, see what I got on my list, and we'll get over to the models. I know that's what everybody's waiting for. Got a snow, freezing rain. I just want to look at the, let's see, precipitable water. There's a precipitable water that the algorithm has been adjusted for east of the Mississippi. That's probably all going to turn out to be about the same. I got a bunch of these potential precip charts here. That really doesn't tell me much. So, any potential precip that is this thing done? Yeah, I have to get rid of that one. That's not doing anything for us. Okay. Alright, let's get over here to the models and see what's going on. Now, low pressure over the four corners. Low pressure over the Gulf of Mexico. That little bit of convection we picked up on off the west coast of Florida. This is the first forecast for 6 hours, and then low pressure over off the east coast. Looks like some freezing precipitation already in. Where's that? Massachusetts, Connecticut. Let's see. There's Northern Virginia. So over maybe over Jersey right there. And then obviously over the Great Lakes we were talking about, and then over the higher elevations of Colorado. That low pressure over the four corners, so definitely getting snow over there. That 540 line, here it is on this chart, and I kind of lose it in the blue there. It's kind of going everywhere. It looks like it comes out and goes to the south and then back up, so everything cutting right through that green and that blue. Alright, so let's go ahead and knock these charts forward. Okay, first thing we got is that low pressure system dropping to the south. The snowfall over the panhandle, and that's pushing south, back south into Texas, and then it looks like we got a mixture line dropping all the way south over the eastern part of Texas, and then maybe some icing there, Corpus Christi, Galveston, and then we got that mixture line through Tennessee, northern Mississippi, stretching up into Kentucky. And then now we really jump up to the precipitation amounts. And that snow stretching all the way back into Oklahoma, all the way down into Texas, and then up to all the way up to Ohio. Now it does get into the darker, a little bit darker blue in the Ohio Valley, and then mixture to the south. So that 540 line was pretty much right on, hanging out there, and then southern Pennsylvania getting some mixture through the Appalachians, and then Mississippi, Alabama, icing all the way down into Louisiana to the coast. That is just a cold air mass, just sunk all the way down through the central United States. Now it looks like some pretty heavy snowfall there around northern Louisiana into Arkansas, and even western Mississippi. So, and then just snowfall continues. Now this is for 0Z on Tuesday. This is Monday night, about 7 p.m. So we back this up real quick. Looks like two little systems running through there. Mixture, and then they kind of become one and then push to the northeast, and then looks like pushing out of the Ohio Valley looks like Tuesday morning. And then New York just getting covered up. The low pressure system over the East Coast, and that's just bringing that onshore flow, wraparound moisture. Got your freezing mixture line right there through Maine, stretching all the way back down into Pennsylvania, and then snow all to the north. And then that low pressure system pushing off to the north, the high pressure kind of ridging in, and it's just slowly just moving to the east. I think our upper level flow was just west to east flow, and pretty straight. We did have that upper level troughing over the four corners, supporting that low pressure system, but you can see that it looks like a low pressure that's dropping to the south. Now we're getting all of a sudden just getting another batch of moisture, maybe that inverted trough, warm air advection off the Gulf, pushing up into Texas, and then causing some freezing rain, pushing back over that cold air mass and all the way up into Oklahoma, and Oklahoma's just covered in snow. And then that hangs out there. This is like, these things are every 6 hours, so. And then it looks like developing some convection. Louisiana stretching up into Mississippi. And then that low pressure system just pushing off to the northeast. Now we got up into the Ohio Valley. Now we're getting into a line of mixture, stretching from the Ohio Valley back into all the way through Arkansas into Louisiana. So, but that's some more snowfall there for us. Indiana, Illinois, Missouri, Arkansas. I mean, you're just looking, pushing all the way to the north, and then just continuing to hammer Illinois, Indiana, and then it looks like the convection, maybe some heavy rain pushing up through the Ohio Valley. How that's going to make the roads, and if, then the high pressure, if the high pressure pushes through, just become just a big ice. See, that's just a lot of icing right there. That's going to be ice over that snow. It's just going to be nasty. Now Pennsylvania, you just got an ice storm coming through all through the Appalachians, and Pennsylvania, southern Pennsylvania, just big heavy area of icing. Like I said, these models change every day, so you kind of take this with a grain of salt. Like I said, the precipitable water we had on our chart was 5 inches. That was just one chart. There's one day. That's right now. That's not, this is like 126 hours out. So I'm talking about precipitable water we had just at that moment. Now this low pressure system redeveloped back over the Gulf of Mexico, picked up a bunch of moisture and brought it to the northeast. I mean, like I said, this is the one. This is Friday, and this is the one I mentioned last week that could be, the perfect storm that went through in 1993. I mean, that's kind of almost the same path. Well, I could pull the charts on that. Actually, I'll go do that. Actually, I think I have a chart saved from 1993. I could pull a surface chart on the program I have, and we can get a good look at that. So that low pressure system just centering right over Ohio, and then finally pushing off, and then it looks like just ridging high pressure well to the south and then clearing out. So then it looks like a minor or major shortwave coming across the north United States, and then bringing some more snowfall. Looks like rain for the Ohio Valley, snow over the Great Lake region. You got a little bit of snow developing in North and South Dakota, and then over Wisconsin, Great Lakes region, and pushing off to the northeast over New York. And then another clipper looks like it comes down and then gives us some more snow, actually all the way down into the Ohio Valley. And then this is pretty far out though, 240 hours. This is Wednesday, February 24th, and then that low pressure pushing off, and then another clipper. And then that looks like mostly rain to the south. Then we got another whole area of mixture. This is just so far out, there ain't no reason to pay attention. We know that's going to change. So let's go look at some probabilities real quick. This chart, National Weather Service, NOAA, probabilities. If we look to the left, we can see the line that shows our probability percentages based on the colors. So now we're at 1 inch right now, and anywhere in these areas, this is from 0Z Sunday, 7 o'clock Saturday night until 7 o'clock Sunday night. So 0Z Monday. Then we can go 6 hours later, or actually that'll be the 15th. See, that's the 6 hours later. It says 0Z. They're supposed to be, see, day 1, day 2. Okay, we're only going every 6 hours. Alright, so 1 inch. So you have 1 inch, 95% probability to have 1 inch over the central United States. Monday, February 15th, 06Z. These are all from Monday going into Tuesday. So this is pretty much our snowstorm that's pushing through the Northeast that where we're gonna have our best chances of precip. So now we're pushing up into the Ohio Valley. We're getting a little bit into that blue, like 50 to 70% chance to have 1 inch of precip. We're gonna go 2 inches. Now Ohio drops all the way down to 1 to 5%. Then still in the central United States, we're still a 90% chance you're gonna have 2 inches of snow. 4 inches of snow gets a little bit smaller, and then you're at 80% in central Oklahoma. Now 10 to 20% still in Oklahoma. That's to have 6 inches of snow. Let's go forward in time now. 18Z Monday. Now the line's stretching up out of Texas. Now we're getting that. Now we're getting into Tuesday, 06Z on Tuesday morning. So this is basically when that system pushed out. I mean, it's going to say we have 20 to 30% chance in the Ohio Valley to have 6 inches of snow. Looks like Kentucky, western Kentucky, and then southern Indiana, you got about a 5 to 10% chance of having 8 inches of snow. So everybody, well, I can't say everybody. Some people are calling for 4 to 6 inches. All these charts are going to say is 4 to 6 inches. Now, if you get to the north there, that was at it's Tuesday, 18Z on Tuesday. Northern Pennsylvania through New York. Now you're looking at, that's 6 inches. 8 inches. There's a chance for 12 inches here. Just a 1 to 5% chance of a 12-inch snowfall. But you see all that precip that was coming through. Now, one thing that's got to be accounted for too is the ratio of rain to snow. Typically, you're 10 times. If you have 1 inch of rain, you have 10 inches of snow. So it's a ratio of 10 to 1. So if you take and double that, because if we looked at the upper level charts and we still had moisture all the way in the upper levels, so now you're saturated from the surface all the way to the upper levels, then you're going to have a heck of a lot more water content. So if you double that, you can pretty much double your amounts. Now you go, 8 inches, 12 inches, you'll be 16 inches. I mean, in the upper elevations, that's not unheard of. Now, in the Midwest, through the Ohio Valley, let's get back here to the 06Z on Tuesday. See, there's really no chance for an 8-inch fall, but there will be if there's we got a pretty good chance for a 6-inch fall. So we're looking at a foot, so I bet we're looking at a foot or better if we, if that system plays out the way it is. If it comes out of the Gulf of Mexico, it's pretty much got the moisture. It picks up that moisture and brings that inland. Then you got what you need for that to happen, to double that snowfall. So, all right, let's get out of here. Go look at another model real quick for. This is pivotal weather. Let's see what we got. Let's go back this up. See if I can go. Alright. Let me see if I can get to a see that time frame on the top of this thing. Alright, so this is Friday on the 12th, 2 days ago. Saturday. This is potential accumulated snowfall. So if we go to that Tuesday, after everything's said and done and pushed out of the Ohio Valley, then what was it, 06Z? Now we see what this says here, 10 inches. 9, 10, 11. Northern Kentucky 11. 9, 8 to 11. Basically 8 to 11 inches through the Ohio Valley. So we can pretty much double that precip. I mean, this is, if this one's accurate, I mean, this goes out pretty far too. If we, this just keeps adding and adding and adding and never erases to start over for the next storm. Well, I mean, if the snow melts, I mean, that's the thing. If we get that rainfall, how much of that snow is going to melt, if any? So that's pretty much it there. So after everything's said and done, everything's going through, we could have about 15 inches of snow, 16, 17 inches of snow on the ground. So you're looking at 18 all through there, 14, 13, right here. Here in Pennsylvania, New York, this is where they're getting hit the hardest. And after all that's said and done, 27 inches. I seen in there 27, 30. I seen a 30 in there, right there. 34, 34 inches in central New York. So, see how that plays out. Now, up in the higher elevations, this saying 69, 71 inches, 94 inches, 105 inches, 102, 101. I mean, that's just nuts. 137, 223 inches of snow. I don't know what this is all about. I mean, that snow doesn't melt over there this time of year, so keep adding to it. This is pretty far out too, so it's a 384-hour forecast, so you got to take that with a grain of salt too. But it's fun to look at, I guess. Alright, let's go check out some radar. Where am I at here? Okay. Florida. Look at these storms here. Actually, we got a couple little hail indicators there. Let's go look at those. There's one right now. This is current. That is 0% chance for possibility of severe hail, 30% chance of a quarter-inch hail. So that's all that is, but that's some convection. We were showing that on that convective chart. That's a pretty good convective chart that program develops. So just off the west coast of Florida. Now if we go to over the Panhandle. Now let's go back to this one real quick in Tampa. Let's go look at, I want to check something out on this one. Look at the vertical integrated liquid. Yeah, that's not much going on there. So there's no real potential for severity on the storms. I mean, you're just your little line of thunderstorms. Let me go back to composite reflectivity. Go up into the Panhandle. Got some precip, maybe some isolated stuff, a little bit of convection maybe. Nothing to worry about. maybe some heavy rain. Really no convection, just heavier rain. It's Mobile, Alabama. And you get the lines off the coast to the south. Shoot over to Louisiana. Now it looks like we're getting into this freezing area. This is just some isolated stuff, but it's still picking up some stuff out there. Maybe Dallas, Fort Worth. Now we're getting into the snowfall, the Panhandle. Light to moderate snow. Oklahoma and Texas. There's Oklahoma City. Still some light to moderate snowfall there. I'm going to download that loop. We can check it out. I want to go over to the Four Corners, see if we can see that low pressure system. If there's anything significant going on over there. So I'm building up pretty decent there. Alright, let's get, we're in New Mexico. Click on the radar. There we go. Now we did say that line was coming up through New Mexico. That frontal system. And then that separating those air masses. We've seen the temperatures on each side of that air mass. So there's we got the rain to the south and the snow. And that looks like maybe some heavier snow closer to that radar. So there it is. Alright, now we got south of the Four Corners. Let's get up in here real quick. Now we got the mixture, like I said, see that rain snow line coming through there. Got that snow to the north, rain to the south, maybe a little bit of freezing rain in the upper levels there, the higher elevations. So, and then rain, mostly rain in southern Nevada. So that's pretty much it. Alright, so like I said, as far as that snowfall, we gotta keep an eye on that stuff. Let's see what we got. Here's the current radar. And Colorado, east side of the mountains through the Continental Divide. Great Lakes region, a little bit of mixture down to the south. Like I said, a little bit of mixture through right there. That line is going through New Mexico up into Colorado across the Four Corners. That's where that rain snow line is. Freezing rain in Northern Virginia, DC, and then any icing or stuff over there. And then we got just some little bit of stuff through the central United States. Some of that could be real, some not. Just some isolated snow showers. So alright, there we go. Till next time, visit Meteorology101.com and get your head in the clouds. Thanks for watching.